standalone and non-standalone 5G new radio, or NR. SIM-equipped and non-SIM devices can also be supported. And a service-based architecture allowing and presenting or exposing these APIs, allowing developers to create new applications with agility and speed. Capabilities include the ability for a UE to connect to multiple network slices simultaneously, which would then be mapped to different data radio bearers, or in some cases even to the same data radio bearer. Improved and simplified quality of service compared to 4G, and the ability to access networks through a local distributed data center, for example, or through centralized networks or centralized cloud data center. And again, notice the clear separation here between the control plane and the user plane. I can just represent that with this division point right here, if you like, where everything below here is user plane, and then everything up here is control plane. And that, again, allows a separation between the two, which means that user plane functions can be distributed or centralized in the core. And that can be done distributed through localized data centers, which are close to the access network, the base stations, and where the users are located, or for certain centralized applications, we might want to move the user plane more centrally located in possibly a public cloud or a nationwide cloud or something of that nature. And when you look at these different functions within the 5G core, the names, if you notice, look somewhat similar to what we've been used to with 4G, with some notable exceptions. So access and mobility, session management, this was pretty much a function of the mobility management entity within the 4G core. And now we have separate network functions, possibly virtualized network functions, that can serve that purpose. And as you can see from the G-Node B interface perspective, we have interfaces to the AMF, which is the access mobility function, via what used to be the S1 MME, which has now got new names for the interface, the N2 interface, and then the N1 interface, which carries the NAS or non-access strata messaging between the UE and the AMF. The AMF communicates directly with the session management, and then the session management has a control plane interface to the user plane functions, or the UPFs. Unified data management, this is really like the HSS, the home subscriber server, where we have the 5G subscriptions. Policy and charging rules are in the policy control function, and we have network exposure functions here which expose the APIs so that outside developers can view those APIs and write applications around those APIs. And then acting like in authentication AAA, we have the authentication server as well. Network slice selection function is basically going to allow selection of different network complexions, as we discussed previously, where a different type of maybe low latency network slice would be selected. This could be provided through a localized data center control and lowering the latency. And then also we could have another network slice provided to the same user equipment or the same device, maybe a robot as in a previous example, and then that may be controlled through a more centralized location. Once again, flexibility is really the key here. So taking that comparison maybe a step further, if we remember how LTE was deployed originally, and we had our home subscriber server, our MME, our user plane packet gateway, and actually that's a mistake. That should be a serving gateway and then a packet gateway, and then our policy and charging rules functionality here as well. Then there was no real distinct differentiation between what was a control element and what was a user plane element. And so with the development of the EPC towards supporting 5G for non-standalone applications. And then, as you can see, we now separate out the control plane functions of the serving gateway and the packet gateway from the user plane functions of those applications here. And so we went through this centralized control plane and user plane separation. So when we look at the 5G core architecture, it looks intimidating, but when you look at it carefully and you start to compare it maybe to what we have known, then as you can see, the authentication server function here is very much like the HSS working with the Unified Data Manager. Policy charging is handled by the policy control function, as you can see here. Session management is a separate function now from the access mobility function, but that acts like an MME, and also the control plane side of the serving gateway and the packet gateway as well, because that interfaces through a control plane to the user plane function, which was the user plane portion of the serving gateway and the packet gateway. Service-based interfaces are used in the 5G core. The control plane network function provides one or more of these services. The network function service then consists of operations based on request, response, or subscribe notify model, which is a REST protocol. And the common protocol used is HTTP, which is used for communications with and exposing the APIs. We're replacing more common protocols that we used in the past, like diameter and GTP control. And this really simplifies the programming interface to the 5G core.